Hi everyone. So in this session, we will be discussing the divergence theorem. So this falls under the topic of mathematical physics, right? So from the divergence theorem, many problems usually comes in your JAM physics examination. So to have an overview of this, uh, we will go through this session, right? So next now go to this statement of the divergence theorem, right? So F is denoted by Pi plus Qj plus Rk be a vector field with a continuous partial derivatives, right? So F is a vector field with a continuous partial derivatives and V be a solid closed bounded region in the space. So B is the solid closed bounded region in the space, right? So if del V be the closed surface uh, that encloses V and N be a outward unit normal vector to the surface, then the divergence theorem states that the volume integral of del dot F means divergence of the F into dV equal to double integral del V into F dot N ds, right? So this is the mathematical form, or better to say the mathematical expression of the divergence theorem. So this has to be taken care, this is to be remembered while solving the different problems, right? So what so the it's so from the conceptual perspective, we can have that in the left hand side what it is. So the left hand side computes the total divergence, that is the net outflow, right? Inside the volume. And for the right hand side computes the total flux of the vector field across the boundary surface del V, right? So right hand side and the left hand side expressions are given. So the theorem tells us now the net outward flow of a vector field in a closed surface is equals to the sum of the sources minus sinks inside the volume. So this is the theoretical definition of the divergence theorem. So it's basically the influx and the outflux related to a surface or a better to say a volume V, right? So it's a relation between the influx means inflow, net inward flow, and the sum of the source and the sinks of the vector field across this volume V. So we can relate those by using this divergence theorem, right? So next go to the mathematical breakdown or mathematical how we can express this in the mathematical way. So in the mathematical way, F can be written as P, X, Y, Z, I cap, and Q is also a function of X, Y, Z, J cap, and R is also a function of X, Y, J, and which is K cap, right? So if we compute the del dot F, so it's the dot product, so it will be del P, del X, del Q, del Y, del R, del Z, right? So similarly, we can easily compute the volume integral and the surface integral as well, or the surface integral for flux as well. Okay. Next, coming to the example. So examples are important for gaining the conceptualization of the means mathematical statement which was given in the first line, right? So F is given by F is small xi plus yj plus zk and V be a unit cube which x is xyz lies between 0 to 1. So it is an unit cube. So it is an unit cube which xyz all lies means all vertices are all this one means if it is x, if it is y, if it is z, then it will be 8 is 1 0 0. Then it is xy plane. So xy plane means 1 1 0. Similarly for this one, 0, 1, 0, 1, Z. So this is Z. This is Z means 0, 0, 1. So similarly for this is an exact plane 1, 0, 1. Similarly, this is um, so this is YZ plane, right? So 0, 1, 1 is XY plane 1, 1, 0. Similarly, 1, 1, 1. So it is this is an unique group. So we need to compute the divergence, right? So divergence will have L dot F. So F is given xi plus yj plus zk. So we'll directly have the divergence value dot product between them. So we'll have 3, right? So similarly, we can compute the volume integral. So the volume integral will be also over the whole surface, so it will be 3, right? So if we want to compute the surface integral, we compute the flux through all the 6 faces of the tube. Means we need to compute means all the from this positive as well as negative. So the x is taken as first means as x varies from 1 to 0. So it is taken first as 1, then as 0, and then n is plus I and nx is minus I. So after computing this, we'll get for x it is 1. Similarly for y phase it will be 1, and similarly for z phase it will be 1. Right? So after adding all these things, we'll have 3. So this will have both volume and integral result as 3. Similarly, the surface integral result is also 3. Hence, LHS and RHS are true, and hence the divergence theorem is been proved or valid, right? So what are the applications we are looking for? So it is been applied in fluid mechanics, net fluid, leaving a volume. So it fits all related to volume matters and volume related fields. The electromagnetism in the Gauss's law. Next is the heat transfer sourcing distribution, aerodynamics, net air motion through the surface, and computational geometry, volume and flow approximations problem, right? So it is a vital formula, that is the divergence formula. So everything, so you should be aware of that, means what are the terms in this means formula, and how what is the physical importance of this formula. That after that it will be clear to everyone. Hope it is clear. I think so. Thank you for this session and have a nice day.